when you try to remove an electron. So if you have a small ionization energy, that means it doesn't take much effort to remove the electron. As a result, metal have small ionization energy. Therefore, they lose electrons easily. Now, another term which we will discuss, both of these terms, ionization energy, electron affinity, these terms we will look at them in chapter 8, a little bit later this semester. Okay, so and they also have a small electron affinity, meaning they don't like to take electrons in. Okay, so in this case, they gain electrons with difficulty. So the cation formation or positively charged ion, formation of a positively charged ion is favored. As for metal. Now the other side of the coin, of course, is for non-metal. So we ask the same question: why do non-metal gain electron? Well, non-metals will have very large ionization energy. Meaning, if you are trying to take electrons away from them, they're not going to be happy. You've got to spend a lot of energy and use a lot of energy to take the electrons away. So they also have very large electron affinity. So when you give them electrons there, they become happier, and so as a result, they form anions easily. Okay, that's the underlying reason. But we will take a look at what we call the periodic trend of periodic properties of the elements there in chapter 8. When we look at those, in chapter 7, chapter 8 there, when we look at those terms there, when we are looking at those different terms there in those chapters there, we will understand why metals tend to lose electron, why non-metals tend to gain electron. For now, we just need you to remember this: metal will give out electron, non-metal will gain electron in a chemical reaction there. Okay, so after losing or gaining electron, what you get is what we call the ion. Now remember the first learning objective there. We still need you to be able to determine the number of electrons and protons and neutrons for not only a neutral atom, but also an ion. So oxygen atom tend to gain 2 electrons. You form oxide ion. So when you have oxide ion, these numbers, this still represent the number of protons. This is still the number of neutron plus the proton. So if we ask you to determine the number of proton, neutron, electrons of an anion here, you need to pay attention because the number of electrons have changed. You need to pay attention to the charges. Okay. So how many protons do we have? 8. Neutrons? 10. 18 minus. Electrons?
8.
Right here, 10. Well, you have 8 to begin with. 2 negative means you get 2 more. So you have 8, you get 2 more, you get 10 electrons. Okay? So for anions, you are adding the number of negative charge to the total number of electrons. So 8 plus 2 gives you 10 electrons. So that's one thing that we need you to be able to do. Given an atom, atomic symbol there with the atomic mass and with the mass number, atomic number there, you need to be able to determine P and N and E. Okay. Given an ion, you have to pay attention to the charges here. 2 negative, meaning 2 extra electrons. So the total number of electrons is going to be different from the neutral atom there. It's going to be whatever you have to begin with plus the extra number of electrons that you gain. What happens to the cation then? Aluminum, 1327, 3 plus. Number of protons, 13. Number of neutrons, 14. Number of electrons. We have to understand what this means. 3 plus means you lost 3 electrons. So you start with 13 electrons. You gave out 3 electrons. How many?
10.
10 left. 13 minus. So for a positively charged ion or cation there, the number of electrons is how many you start with minus whatever the charges you have there. Okay.